Hi friends, today we are going to learn about the nuclear magnetic resonance spectroscopy of third year chapter. What is NMR? NMR is the spectroscopy which have more advanced technique to determine the structure of molecule which is derived from interaction of matter with the radio frequency waves. It is the spectra uses radio frequency. These are the sample of record to be recorded is placed between the two bar magnets, heavy magnets. The protons are behaved as a teeny magnets or microscopic magnets, which are in the motion. It is known as precision motion. This precision motion creates a bar magnet which have different orientations and different environments. Coming to the principles of NMR spectroscopy, we are using radio frequency waves. In short, RF radiations which have longer wavelength and lower frequency and lower energy wavelengths. In nuclear magnetic imaging MRI, which are used in medical science, are similar have similar principles in which radio waves are used, and the big magnet of heavy magnets are used to determine the image of any particular disease are identified by the this NMR technique. We use radio frequency as these these are NMR spectrometer. Here are the conditions for nuclei to be a active nuclei in NMR. It must have odd number of proton and odd number of neutrons, which have property called spin. H1 NMR, 1 proton and 0 neutron have spin, whereas in helium deuterium nucleus, 1 proton and 1 neutron have also have spin, while in helium, even number of proton and even number of neutrons have no spin. Hence, it is NMR active. Like carbon 12 and carbon 12 have 6 proton and 6 neutron, while carbon 13 have 7 proton and 7 uh, 6 proton and 7 neutron, which have also spin. Only nuclei which have spin are detected by NMR. No other nuclei is active in NMR spectroscopy, only which have spin. The spin has value I, which can either be a integer or half integer. Nuclei with odd number of protons and odd number of neutrons are odd number of protons and odd number of neutrons have integer spin. There are only a handful of integer spin nuclei like deuterium, lithium. Nuclei are charged particle, proton are positively charged. Moving electric charge generate magnetic field. It is a basic principle. Any moving body produce magnetic field. Here, the proton behave as a teeny magnet, so which have south and north pole. Nuclei are no exceptional. Nuclei with spin generate their own teeny magnetic field and so behave like a bit of magnet, which magnetic field revolves, move through north pole to south pole, which is the overall. This is the north pole. We can represent the magnetic moment of our nuclei using single arrow. Here is the north pole and north to south pole. The magnetic moment, which is indicated by this arrow, points towards the north pole. In simplification of this, we are representing this overall nucleus as one downward movement. So, using bar magnet analogy, this is opposing the spin magnet and this is up with the magnets. Under normal condition, all nuclei are in random manner, that is known as degenerate state. There is no energy difference from one orientation to another. When we applied external magnetic field, these nuclei get aligned or opposed with the external magnetic field. These are the direction of external magnetic field. The total number of spin state available to the nucleus is in applied magnetic field is given by number of spin state. That is to determine how many orientation are there aligned and opposed. There is a formula 2i plus 1. This 2i value is a integer r. For proton NMR, it is I value is half, hence the only two orientation is possible. In case of deuterium, there is I value is 1 and the spin is 3. There are three orientation. In C13 also there are two orientation possible. Here is by conventional, the applied magnetic field referred to as B0 and it is always applied along the Z axis, which this nuclei is against the applied magnetic field direction, hence it is more energetic, aligned against the field. It is also known as beta level, while with the with the aligned with the external magnetic field, that region is known as alpha level and have lower energy state. When it is when nuclei in the absence of external magnetic field, in the absence of magnet, it is in the degenerate state. When we apply external magnetic field strength B0, the high energy swing state is aligned against, that is beta level, and the low energy spin state aligned with the external magnetic field B0. This orientation are possible and the gap between these two states is known as delta E, which is as the applied field strength increases, so does the delta E value also increases. It means when we use more strength, stronger magnet, the gap between these two levels are increases or decreases depending upon the strength of the magnet. So when we see, we get NMR spectrum from applying energy to the system in the form of varying. We apply the population. Here is the concept of population at the alpha level and beta level, that is opposite state and at the lower state. When we give sufficient energy to the alpha level, it moves, these protons are reach to the beta level by accepting a particular amount of energy. Here, if we give higher RF radiation or lower, there is no match. When delta E is equal to the RF radiation frequency, then it is known as resonance. The particular frequency is used as a resonance. Here is the frequency of RF radiation which is observed induced resonance which cause a peak to appear in the spectrum at specific frequency. Here this is the particular frequency of RF radiation corresponding to energy of EI. This is the real spectrum of any NMR spectrum of the given compound. This is a complex one. Here it matches. We can calculate the delta E value by given equation, Planck constant, gyroscopic ratio, and Bohr magneton in Tesla upon 2 pi. Here is the calculation per proton NMR spectrum. That is, we calculate, this is the final value of calculation. Here is the gap between the delta E, that is lower energy state, and the opposed orientation, that is beta level and alpha level. We see the population's concept. Population concept is how many protons are at beta level at the given time and in the alpha level. Always lower energy have higher number of protons. When we applied external RF radiations, it absorbed energy and moved to the higher level, and the beta level population get increased by 1. We can see the absorption goes on. When it reaches equal number of protons, equal population at the alpha level and at the beta level, it is known as a saturation point. This is not good for the NMR spectra. We can counter this by relaxing, or it is also known as stimulated emission, not net absorption of energy, and it does not give the NMR spectrum. To counter this, we take relaxation. We stop the spin lattice relaxation. We take uh, stop RF radiation, and higher energy level protons get emitted their energy and goes to the backward to align orientation. This is the more spin flip, stronger NMR signal, but saturation and issue. Allow sample to relax between RF pulses combined average data. This RF radiation, again we apply RF radiation and promotion of electron from lower energy level to higher energy level.